Hello, I'm Jacob Cook, and I'm currently a mechanical engineering student at IUPUI. For my project, I interviewed Rochelle Palmer, a current product engineer at Cummins Inc. Cummins currently has a problem where it is hard to detect cracks in the plastic electrical joint on inlet metering valves. They commonly refer to it as IMV in field returns. These cracks can cause mechanical dump valve pops, rail pressure instability, and intermittent electrical connection. Previous tests have been performed to try to detect these cracks. These tests included performance, resistance, inductance, and saltwater dunk tests. A new testing method is needed to detect these cracks. Requirements of this new test method are low cost, quick, and at least 75% accurate. This in the left hand corner right here, this is a Cummins IMV to give you an idea of what it looks like. This is the elbow piece here. This is plastic, and they're trying to determine how many of these parts are getting cracks in them that you can't see. When they know how many of these are getting cracks, then they can make a decision on whether they need to strengthen that part or make some sort of change. So during this presentation, we're going to cover 3 methods for detecting cracks. The first method is acoustic microimaging, also referred to as AMI. The advantages of this method is it can detect very small defects, can look at multiple specimens at a time, so you can look at many parts at once. It's fast because you can look at many parts at once. The disadvantages are this machine is very expensive. A used one on eBay costs about $8,795. Another disadvantage is it requires special training. You'd have to send an employee somewhere to learn how to run the machine. Another disadvantage is high frequency waves have limited penetration, so it can't detect the cracks that may be occurring on the inside of the part. The second method is X-ray computed tomography. Advantages of this method are it can detect very small cracks. It has good penetration, so if there's cracks on the inside of the part, this method would find them. Disadvantages are this method is expensive. A X-ray tomography machine costs $35,000 used on eBay. You would also have to send an employee out for special training. You can only look at one specimen at a time, so you could only have one part at a time, making the method a bit of a slower method compared to the other ones. Dye penetration method is the third method. It's easy. Anyone can do this method. It is only 5 steps. And you can find these 5 steps on Magnaflux's website. It's inexpensive, with costs ranging from $423 to $2,145. That depends on the UV light that you want to purchase, because there's a professional UV light and then there's just a simple UV light that you could buy from Walmart. The next advantage is you can look at multiple parts at a time, making this a very fast method. Disadvantages are really small cracks may go undetected, and only surface cracks can be detected using this method. My solution would be to use the dye penetration method for detecting cracks in plastic for this application. As you can see from the chart, its advantages outweigh the advantages of the other methods. No data was able to be found on the accuracy of these methods. My next step would be to set an employee up with the steps and order my supplies offline. During this presentation, we discussed 3 methods to detect cracks in plastic. When the 3 methods were compared, it was found that the dye penetration method was the best method to use next. It is the simplest method. It requires no special training. Any employee can be taught how to do it. It is the least expensive method when compared to the other 2. And finally, it is the fastest method because multiple parts can be looked at one time. Thank you for listening. Do you have any questions?